92% of AI agents fail in production, but Nvidia just decided to fix that by giving away their secret sauce for free.
Free? Are you saying they're open sourcing their enterprise AI agent platform? So we're covering NemoClaw's architecture, the privacy tools, and how this works without Nvidia chips?
By minute 4, you'll know exactly why this kills half the AI startups out there. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today we're diving into Nvidia is planning to launch an open source AI agent platform.
Stick around to the end for today's headlines. Let's dive right in.
So, Nvidia is planning to launch an open-source AI agent platform, and this is genuinely one of the most strategic moves we've seen from them in years. We're talking about a company that's worth over $3 trillion, that's trillion with a T, and they're essentially saying, hey, we're going to open source a major piece of our AI software stack.
Which feels counterintuitive, right? I mean, when you're sitting on that kind of market dominance, why would you open source anything?
That's exactly the right question. And to understand why this matters, we need to zoom out a bit. Nvidia has completely transformed over the past decade. They went from being the company that made your gaming graphics card to becoming the backbone of the entire AI revolution. Every major AI model you've heard of, ChatGPT, Claude, Gemini, they're all trained on Nvidia GPUs.
And the numbers are just staggering. I was looking at their quarterly earnings. They're doing something like $26 billion in revenue per quarter now, mostly from data center sales.
Right. And here's where it gets interesting. Their customers, companies like OpenAI, Microsoft, Google, they're all desperate for these chips. There's literally a shortage. Companies are waiting months to get their hands on H100 GPUs. Some are paying $40,000 per chip on the secondary market.
So if you're Nvidia and you have this incredible hardware mode, why pivot to open source software?
Because they're playing a much longer game here. See, the hardware dominance won't last forever. AMD is catching up with their MI300 chips, Google has their TPUs, Amazon's building Trainium chips, even Apple is getting into the game with their M-series processors handling local AI workloads.
But Nvidia still has CUDA, right? That's been their software moat for years.
Exactly, and that's what makes this move so fascinating. CUDA has been their secret weapon since 2006. It's the programming platform that lets developers actually use GPUs for computing, not just graphics. But here's the thing. Customers are starting to push back on vendor lock-in. They don't want to be completely dependent on one company for both their hardware and software stack.
So this open source platform is their response to that pressure?
It's more than that. They're calling it an AI agent platform, which means it's specifically designed for building autonomous AI systems, not just running models, but creating agents that can actually take actions, make decisions, interact with other systems. Think of it as infrastructure for the next generation of AI applications.
Oh, so we're talking about AI that can actually do things, not just generate text or images.
Precisely. And the timing here is critical. We're right at this inflection point where enterprises are moving from, let's experiment with ChatGPT, to how do we actually build AI into our core business processes? But building AI agents from scratch is incredibly complex. You need orchestration, memory management, tool integration, safety guardrails.
And right now, most companies are cobbling together their own solutions or relying on proprietary platforms.
Which is expensive, risky, and slow. So Nvidia is basically saying, here's an open source foundation you can build on, and oh, by the way, it runs best on our hardware. It's brilliant, really. They're commoditizing the complement while maintaining their core advantage.
Coming up, we'll dig into exactly how this platform works and what it means for developers who are building AI systems.
So let's get into the technical architecture of what Nvidia is building here. Based on what we know from their recent announcements and patents, this isn't just another framework, it's a complete reimagining of how AI agents should work.
Walk me through the stack. What are the core components?
At the foundation, you've got what they're calling the agent runtime. This is essentially a lightweight orchestration layer that manages the life cycle of AI agents. Think of it like Kubernetes, but specifically designed for AI workloads. It handles resource allocation, scaling, fault tolerance, all the operational stuff that makes distributed AI systems so challenging.
And I'm assuming this integrates directly with their GPU scheduling?
Not just integrates, it's optimized for it. They're using techniques like dynamic batching and tensor parallelism that can increase throughput by 3 to 4 times compared to naive implementations. We're talking about being able to run hundreds of agents simultaneously on a single DGX system.
But here's what I don't get. How do you make something like this truly open source while still maintaining a competitive advantage?
That's where Nvidia is being really clever. The core platform is open source, but they're building a whole ecosystem of accelerated libraries around it. So yes, you can run this on any hardware, but if you want that 3-4x performance boost, you need their GPUs and their proprietary CUDA kernels.
It's the classic free razor, expensive blades model.
Exactly. But let's talk about what developers actually get here. The platform includes pre-built components for common agent patterns. You've got memory systems that can maintain context across conversations, tool calling interfaces that let agents interact with external APIs, planning modules that can break down complex tasks.
How does the memory system work? That's always been a challenge with LLMs.
They're using a hierarchical approach. Short-term memory lives in GPU RAM for fast access during active conversations. Medium-term memory gets offloaded to system RAM with intelligent caching. Long-term memory is persisted to vector databases. But here's the clever part. They're using semantic compression techniques to reduce storage by up to 90% while maintaining retrieval accuracy above 95%.
That's huge for cost management. Storage has been killing us on our current AI projects.
And it gets better. They've built in native support for RAG, Retrieval Augmented Generation. The platform can automatically chunk and index documents, maintain embedding caches, and even do intelligent prefetching based on conversation context. In their benchmarks, they're showing 40% reduction in latency for knowledge-intensive tasks.
Those numbers sound almost too good. What's the catch?
Well, there are several. First, you need significant expertise to properly configure and tune these systems. We're not talking about a simple pip install here. Second, the resource requirements are substantial. Minimum 24 gigabytes of VRAM just to get started, preferably 48 gigabytes or more for production workloads.
And I'm guessing the learning curve is steep.
It's definitely not trivial, but they're addressing this with extensive tooling. There's a visual workflow designer for building agent behaviors, built-in debugging and profiling tools, even a simulation environment where you can test agents before deploying them. They're clearly trying to lower the barrier to entry.
About safety and governance, that's been a huge concern with autonomous AI systems.
This is where the open source nature actually becomes an advantage. The platform includes pluggable safety modules, think guardrails for preventing harmful outputs, audit logging for compliance, and even built-in support for constitutional AI approaches. And because it's open source, organizations can inspect and modify these safety systems to meet their specific requirements.
That's smart. It addresses the black box concern that a lot of enterprises have.
But here's the really interesting part. They're not just open sourcing the code, they're building a whole ecosystem. There's a marketplace for pre-trained agents, a certification program for developers, even talk of a cloud service where you can deploy agents without managing infrastructure.
It's like the Android model, open source core with a commercial ecosystem built on top.
That's a perfect analogy. And just like Android, the success will depend on adoption. They need developers to build on this platform, enterprises to deploy it, and a community to contribute improvements. The technical foundation looks solid, but ecosystems are about more than just code.
Stick around. We'll break down exactly what this means for your AI strategy and give you a practical roadmap for getting started.
All right, let's get practical. If you're a developer or a technical leader trying to figure out what NVIDIA's open source AI platform means for your organization, here's your actionable playbook.
Let's start with the immediate question. Should teams be planning to adopt this?
The answer depends on where you are in your AI journey. If you're just starting to experiment with AI, this might actually be overkill. You're better off starting with managed services like OpenAI's API or Anthropic's Claude. But if you're already running AI workloads in production and hitting limitations with current solutions, this platform could be transformative.
What are the specific signals that a team is ready for something like this?
3 key indicators. First, you're spending more than $50,000 a month on AI API calls. At that scale, bringing inference in-house starts to make economic sense. Second, you need capabilities that current APIs don't provide. Custom models, specific latency requirements, data residency constraints. Third, you have the engineering talent to manage distributed systems. This isn't a set-it-and-forget-it solution.
That's a pretty high bar. What about smaller teams?
Here's where the ecosystem play becomes important. I expect we'll see managed service providers offering hosted versions of this platform within 6 months. You'll get the flexibility of the open source platform without the operational overhead. Think of it like using managed Kubernetes instead of running your own clusters.
So what should teams be doing right now to prepare?
Start with education. Have your team go through Nvidia's Deep Learning Institute courses. They're free and excellent. Focus on understanding agent architectures, not just LLMs. Learn about things like React patterns, chain of thought prompting, tool use. These concepts will be critical regardless of which platform you ultimately choose.
What about from an infrastructure perspective?
If you're serious about this, start budgeting for GPU capacity now. Even with the open source platform, you'll need significant compute resources. A minimal production setup is probably going to run you $100,000 to $200,000 in hardware, or about $10,000 per month in cloud costs. But here's the thing. That same capacity would cost you $50,000 to $100,000 per month using API services.
Those are big numbers. How do you justify that investment?
You need to think about AI agents as force multipliers. A well-designed agent can handle tasks that would require multiple full-time employees. Customer service, data analysis, document processing. These are all areas where AI agents are already delivering 10x or better productivity gains. The ROI can be measured in months, not years.
What about risks? What should teams watch out for?
The biggest risk is underestimating the complexity. AI agents aren't just chatbots. They're autonomous systems that can take actions in your environment. You need robust testing, monitoring, and rollback procedures. Start small with low-risk use cases. Maybe an internal documentation assistant before a customer-facing agent.
And from a strategic perspective?
This is where it gets really interesting. Nvidia's move is going to accelerate the entire AI agent ecosystem. We're going to see an explosion of innovation over the next 12 to 18 months. New agent architectures, better tools, more sophisticated capabilities. Organizations that start building expertise now will have a massive advantage.
It feels like we're at the beginning of a new platform shift.
That's exactly what this is. Just like mobile apps transformed business in the 2010s, AI agents are going to transform it in the 2020s. And Nvidia is essentially providing the iOS or Android of AI agents, open enough to encourage innovation, but with enough structure to ensure quality and compatibility.
Any final thoughts for teams trying to navigate this?
Don't wait for perfect clarity. The teams that win in technology transitions are the ones that start experimenting early, learn fast, and aren't afraid to throw away their first attempts. Build a small prototype. Learn what works and what doesn't. Most importantly, start building the organizational muscle memory for working with AI agents.
Because this isn't just about technology, it's about fundamentally rethinking how work gets done.
Exactly. And here's my prediction. Within 5 years, every software application will have embedded AI agents, not as a feature, but as the primary interface. Nvidia's platform is just the beginning. The companies that figure out how to build and deploy AI agents effectively will be the ones that define the next decade of technology. Before we wrap up, let's catch up on this week's infrastructure news. There is a fascinating development in the AI legal landscape. Google and OpenAI just filed a legal brief supporting Anthropic in what's becoming a major courtroom battle. According to Gizmodo, they're backing Anthropic against the U.S. government's claim that the company poses a national security risk.
Wait, Google and OpenAI are actually teaming up to support a competitor? That's unexpected. What's driving this unusual alliance?
It seems they're concerned about the precedent this could set for the entire AI industry. The brief argues that Anthropic was right to maintain its position, though the details get pretty complex.
Speaking of Anthropic, the New York Times reports they're actually suing the Pentagon over being labeled a supply chain risk. This effectively cut them off from any Defense Department work.
Right, and The Verge adds more context. They're specifically citing actions under the Trump administration. Anthropic alleges this is retaliation for setting certain ethical boundaries around their AI technology.
So they're claiming the government is punishing them for having safety standards? That's a bold accusation.
On a more positive note for Anthropic, AWS just announced that Claude models are now available in India through Amazon Bedrock. They're using something called global cross-region inference for better scalability and reliability.
That significant expansion into one of the world's largest tech markets should help them compete better with OpenAI globally.
Let's shift to some technical news. There's an interesting new paper on Archive about Auto Checklist, an open-source library for creating composable pipelines for checklist generation using LLMs as judges.
Oh, that sounds useful for evaluation workflows. Having modular frameworks for LLM judging could really standardize how we assess model outputs.
Now for software releases. Lite LLM just dropped version 1.82.1 nightly, and it's marked as a security release. The highlights include fixes for Gemini 2.0's JSON schema handling and proper mapping of reasoning effort for Claude 4.6 models.
They're also optimizing spend log deletion for better performance. Always good to see teams addressing both security and efficiency in the same release.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.